Homework number 3, I accidentally put a problem in there that I didn't cover, that actually wasn't in that section. So in homework number 3, question number 5, I'm just going to tell you the answer and you just type it in and move on. Don't even try to figure it out, okay? The answer is 0.775x plus 20. Okay. Type it in, everyone will get it right. Pretend it wasn't even there. All right, we're going to start with lesson number 4. In this lesson, we're going to learn how to use dimensional analysis, which is a way of dealing with units. Okay? We're going to be doing some unit conversions, and we're going to use those two things to help us set up some proportions solving application problems. All right, so imagine that gas costs $3.57 per gallon. Clearly, this was written not super recently, right? Back when gas was a little bit more expensive. So you fill your car with 12 gallons of gas, and then you go into the store and you buy some items for $15.35. How much money are you going to give to the clerk? And before we start typing anything into our calculator to come up with an answer, let's just write down what it is we're going to type in, right? 1 second. Hide this.
Gallons of gas, 357.
Mm-hmm.
It's going to be 12 times 357.
Yep, 12 gallons of gas, 357 per gallon, so you multiply them. Plus the 15.35 for whatever you bought inside. Yeah. So notice that those numbers don't have any units on them. And anytime you write down an equation, the units on the left-hand side has to equal the units on the right-hand side. For two things to be equal, they have to be measuring the same stuff. Okay. So what are the units on the right-hand side of this equation? Because I think this comes out to be equal to 58.19. What are the units on the right-hand side? Dollars. Yeah, 58.19, that's dollars, right? So that means that the units on the left-hand side has to also be dollars, right? Dollars has to equal dollars. So I'm going to examine what happens when I put the units on every single number in the left-hand side to see how we get dollars. Okay, so this $3.57, 357. What is the unit? What are the units on that? Dollars per gallon, right? That's the price of the gas. So this is dollars per gallon. And then what's the units on the 12? Just gallons. That's how many gallons you bought. And then what are the units on the 15.35? Dollars. That's how much money you spent in the store, right? And the units on the 58.19, we said that was dollars, right? Okay. So if we omit the numbers, I'm going to cover this up again. Okay, so if I omit the numbers, the 357, the 12, 15.35, and 58.19, I'm going to do this with just units, no numbers. So I'm going to write out, I have dollars per gallon times gallons plus dollars. Okay. If you multiply dollars per gallon times gallons, you have a gallons on the top and a gallons on the bottom, and those guys cancel. So you end up with dollars plus dollars, which equals dollars. So this is called dimensional analysis, where you write out just the units and see if anything cancels. All right, so we're going to change gears for a minute. We're going to come back to the unit analysis in a minute. All right, so Then we're going to change gears and talk about ratios. And we're going to see that dimensional analysis techniques that we just talked about will help us a lot when we're setting up proportions. So a ratio compares two numerical quantities through the operation of division. And a ratio is often written as a quotient or a fraction, such as A over B. It can also be written A to B or A colon B. So I'm going to solve a proportion two different ways. There's two basic techniques. So here's my original equation. X minus 1 over 7 equals 3/5. The first technique you may or may not have seen is called cross multiplication, where you can just like draw a little butterfly and you multiply the extremes. Okay. So I have 5 times x minus 1 is equal to 7 times 3. It is equal to 5x minus 5. Yeah, that's the distribute step. 5x minus 5 equals 7 times 3, which is 21. And then add 5 and divide by 2. So we get 5x is 26. So x is, we'll just leave it as 26/5. I meant to divide by 5. Sorry. Yeah, divide by 5. So we get 26/5. So that's called cross multiplication. So just a quick poll, who has seen this method before? Okay, about half of you. This is not the method that most of the GCC professors teach in 095. So if this is unfamiliar to you, that's normal. Okay.
Is it that way quicker?
It is pretty quick, yeah. Okay, now we're going to do another method where you multiply both sides of the equation by both denominators. Okay, so this is the one that might feel familiar if you took 095 here. Nope, I'm not adding them together. I'm just going to multiply both sides by both denominators. So the left side, I'm going to multiply both by 5 and by 7. And the right side, I'm going to multiply by 5 and by 7. Multiply both sides by both denominators. Okay, so on the left, I have a 7 on top and a 7 on the bottom, so those cancel. And I'm left with 5 times x minus 1. And on the right, the 5s cancel, and I'm left with 3 times 7, which is the exact same equation we got over here by cross multiplying. So then we finish solving, which we already did over here. You get the same thing, 26/5. Okay, so you can use whichever method you prefer. I don't care. When you're trying to solve a proportion, you can cross multiply or multiply both sides by both denominators. Questions? Yeah.
What do you think is the easier method for harder types of algebra?
So absolutely, that's a personal preference. When I'm solving a proportion, if it's just a fraction equals a fraction, I tend to do cross multiplication. But like if it gets more complicated, where you have a fraction plus a fraction equals a fraction minus another fraction, like then I would go with this method. Yeah. Okay. Fraction equals a fraction, cross multiply. When it's more complicated than just a single fraction equals a single fraction, I go with this method. In fact, you can't do this method unless you simplify first.
Are you going to show us?
No, because we're only doing proportions today. Yep. Okay, so here's a application problem. The ratio of female students to male students at GCC is 3 to 2. If there are 2,000 students altogether, okay, set up and solve a proportion to find out how many are female. So first, we're going to carefully define our variable using a quantity word and a unit word. And my trick for deciding what the variable should be is to pick out the question. In all the words of that word problem, I want to identify just a few words that what did they want to know, right? So I go up and I read and I say, oh, how many are female? That's my question, right? That's what I'm trying to find out. So that's what I'm going to let my variable be. So I'm going to let X be the number of female students. X, so when I find out what X is, I will have answered the question. Okay. So I'm going to just make a quick note. Just writing let X equal females is not a good definition because it doesn't have a quantity word, right? You need to have it be something that you can count or measure. So it has to be the number of female students. All right, so anytime you're trying to solve a proportion problem, you start by setting up a blank proportion. Fraction equals a fraction. All right, so then next, we've got fraction equals a fraction, blank proportion. Next, we have to label both sides of the fraction with some units. Before we put any numbers or letters in, we need to figure out what the units are going to be. So it's not important which unit goes on top and which unit goes on the bottom, as long as the units on the left equals the units on the right. Okay. So I have randomly here put females over males. You could put males over females. Doesn't matter as long as you do the same thing on both sides. Okay, so I've got females over males, which means I have to have females over males on the right side also. Okay, so next, number 10 here. Next, we start filling in the proportion with numbers. Any numbers from the problem, okay? So notice that the 2,000 cannot go into the proportion because 2,000 is not a measurement of the number of females or a measurement of the number of males, right? 2,000 is the total altogether, so 2,000 is not a number that we can put in here. Okay. What numbers can we put in? 3 to 2. We know that the ratio of females to males is 3 to 2. So I put those two numbers in. Now we put in our variable, right? X represented the number of females. So where should I put the X? Top or bottom of the fraction? Top. So I put the X here for number of females. I have one more spot in my two fraction equation for the number of males. This is the trickiest part, filling in this last blank. We need an expression to represent the number of males at GCC. So we have 2,000 total students. How many of them are female? X. Yeah, we don't know. That's the question we're trying to answer. So if you have 2,000 total, X of them are females. How many are males? 2,000 minus X. Yeah. And if that was hard, right, if it's hard to come up with that expression, try picking a number for females, for the number of females, like 500. And you would say, oh, okay, if I have 2,000 students and 500 are female, 1,500 are male. And then you'd say, oh, I subtracted. I do the same thing when I have an X. So the bottom of this fraction is going to be 2,000 minus X. That will give me the number of males. So there's my proportion. 3 over 2 equals X over 2,000 minus X. Questions on how we got there? Yeah. I would want you to solve it. Yep. And I'm going to have you, I'm just saving the solving of this for the class activities. So you're going to solve it. Right. You're going to finish solving it in the class activities. We're not going to do it together on the board. Okay. Yeah. For today, just because we're learning this method, in the future, like we're going to be developing a whole tool set of ways to solve problems. You use whatever tool you feel is appropriate. But today we're learning this tool, so say that again.
Use the easy way.
Today you do it this way. If you find that another method or another tool is easier, like any day after today, you can use that. today we're just learning this, how to use this one particular tool. Okay, so now we're going to do one example of a unit conversion, coming back to units. Okay. In the US, a baby is born every 3.2 seconds. So here's how we find the number of babies that are born in the United States each decade. Okay, how many babies are born in a span of 10 years? So we're going to start with the given data, including units, right? 1 to 3.2. Units are babies to seconds, right? One baby every 3.2 seconds. Set that up as a ratio. Okay. And then I'm going to multiply. I'm just going to keep multiplying by ratios that are actually 1, right? Because you can multiply 1 and you don't actually change the value. But I'm going to use a fancy form of 1. So we currently have seconds in our calculation, and I would like that denominator to actually say decades, because I want babies per decade to be my answer. So I'm going to try to convert my time units here, and I know that there are 60 seconds in 1 minute, right? So I'm either going to multiply this fraction by 1 minute every 60 seconds, or 60 seconds to 1 minute. Notice that these are both actually 1 because there are 60 seconds in 1 minute, right? So 1 minute over 60 seconds actually represents the same quantity on top and bottom, so it's a 1. All right, so which units do I want to multiply by? Minutes over seconds or seconds over minutes? Seconds over minutes, why? Yeah, then I'll have a seconds on top and a seconds on the bottom, and they'll cancel. So this is going to be times 60 seconds every 1 minute. So then I have a seconds on the bottom and a seconds on the top, and I get those to cancel. Okay, so this is what this looks like. You have 1 baby every 3.2 seconds times 60 seconds every minute. The seconds cancel, and now we can calculate how many babies per minute are born. And we're going to finish this problem. I'm going to keep multiplying by the appropriate fraction that is actually 1, right? So until I get to decades. So what unit conversion do you happen to know off the top of your head about minutes? Minutes to hours. How many minutes are in an hour? 60. Okay, so I'm going to multiply by another fraction. And I need the minutes to cancel, right? So I'm going to put the minutes on top and the hours on the bottom, and it's 60 minutes in 1 hour. So then my minutes cancel, and I just have hours. All right, how can you convert hours to a larger quantity of time? Days. Days. So I want to convert to days now. So I'm going to multiply by another fraction. Should I put the hours on the top or the bottom? The top, so that it'll cancel with the hours that are on the bottom. So I'm going to put 24 hours per 1 day. Okay. How do I convert days to a longer quantity of time? Years. How many days are in a year? We'll just go with 365. We'll just go with 365. Won't overcomplicate it. Yeah. So what fraction am I going to multiply by?
365 days.
365 days over 1 year, right? So then my days cancel. And over here, my hours canceled. All right, almost there. How do I convert years to decades? I'm going to multiply by 10 years every decade. So this is times 10 years per decade for 1 decade. So years cancels. And now my units, in my numerator, the only units that haven't been crossed out is baby, right? And in the denominator, the only units that haven't been crossed out is decade. So my answer is going to come out in babies per decade. And when you multiply fractions, just multiply all the numbers on the top, multiply all the numbers on the bottom, And let's see, I did this out ahead of time. No, it's not. That answer is wrong. Yeah. So it comes out to, the numerator comes out to 3, 1, 5, 3, 6, 1, 2, 3, 4. So that's got a unit of babies. Over the only number in the denominator is 3.2 decades. Okay, and then we simplify that fraction down to 98,550,000 babies per year. So the answer typed in the answer underneath is wrong. Okay, so change it, make it right. I multiplied all the numbers in the fraction, right? So I multiplied 1 times 60 times 60 times 24 times 365 times 10. All the numbers across the top of the fractions got multiplied together to make this 315 million number. Yep. And then all the numbers in the bottom got multiplied, just that they were mostly ones. I had 3.2 times 1 times 1 times 1 times 1 times 1, 3.2. And then I divided the 315 million by 3.2. Yes.
Shouldn't that bottom denominator?
Oh, it should be decades. Oh my goodness, thank you. Per decade. Yeah, sorry about that. We just did all that work to figure out the units and I wrote it wrong.